Hi, welcome to Java Programming 1. We're going to cover we're going to cover not the first 6 chapters because there's already chapter 1, which really is kind of more about computers and that type of thing. So go ahead and read that on your own. I believe there's a video out there that I did for chapter 1. But we're going to do chapters 2 through 7 over the next 6 weeks. So you should have also watched the video on how to set up and install Eclipse, and there should also another one how to import those files, those programs that we have out there. I have them out there that in the source code folder that you can actually then import those into Eclipse and kind of follow along. Okay, so before we get started, let's take a look at Eclipse. So we've got Eclipse, and on the left-hand side is what are called Project Explorer, and once we import all of those programs, we're going to see them over here. So let's first take a look at what we have. So once you import chapter 2, you're going to see chapter 2 when you expand it. You're going to see this thing called the JRE System Library. And what that is, that's all of the code that comes with Java. So this is all the pre-written code that we get automatically. Some of it we can use right out of the box, and others we have to say, hey, I need to include this via an import statement, and we'll cover those as we get to them. What we're going to be using is this thing called the SRC folder, okay? And then inside of that, so the SRC is basically that's the main folder, and then we can create subfolders inside of that, and each one of those folders is called a package. So think of the SRC folder as kind of our file cabinet, and then we can create drawers, our file cabinet drawers inside of that file cabinet, and that's what these packages are. These look like little 4 squares together. The name of the package we'll be working out of is called Chap2. So before we get started, let's talk about how do you create a project and what is a project. So a project is a rubber band around a whole bunch of code that's going to be utilized and works together. So how we do that is we come up here and we click File, we point to New, we click on Project, and down here it says, okay, what type of project do you want? And we're going to expand Java and make sure we click on Java Project. So we click that and we click Next. Now this is the project screen, and there's a whole lot of different configurations here. We're not going to get into those in this class, but really all we need to do is give it a project name. Now here's the rules for a project name. The first character must be a letter. It cannot be a number, cannot be a special character. We're actually only allowed to have one special character. So I'm going to call this example. I want to back it up. I'm going to call this Hello World. Okay? So we got Hello World. Now you notice I did 2 things here. Number 1, I used no spaces. You cannot have a space in your project name. The first character must be a letter, and you'll notice that I made world uppercase as well. This is called camel casting. We're going to name things. We can't use spaces, so instead of using spaces, we're going to make sure each word has a capital letter, so it makes it easier to read. Hello World. We can see they're 2 separate words, but they're basically joined together with no space. Okay. We can use after this first letter, I can put in numbers, letters, and underscores. So that's all I can use. I can't use any other special characters. No dashes, no plus signs, no slashes, no anything. All we can use are letters, numbers, and underscores. Okay, so once I have that named, I'm just going to click Finish. If you get that Java perspective, don't worry about that. Just go ahead and click OK. You'll notice now I have this project folder called Hello World. When I expand it, you'll see that it automatically includes the JRE System Library. So we get all of that code that comes with it. The next thing you see is our SRC folder. If I expand that, all I see is this module info.java. Okay, that's really nothing that we need to utilize for this class. So before we do anything, I have to create, so there's my file cabinet, my SRC folder. I need to create my drawer for this particular item. So I'm going to do a right click on this SRC folder. I'm going to point to new. I'm going to come down here and I'm going to click package. Now, the rules for the package are the same for the project. No spaces, and it must be the first character has to be a letter. But there's one rule for this guy, and that is they have to be all lowercase. So I'm just going to call this hello. You can call it anything you want. Now in a real world situation, we might have this project. Maybe we had a project that's called calculate taxes. So I might have a read process and a write process and a calculate process. I might have all these different processes, and I might want to group those processes by packages. So it's really, the foldering system is just for organization, really. It has really no effect on the programming, but it's there for organizing. I have worked on programs that have 15, 20, 30 packages, and each one of those packages can have anywhere from 2 to like 20 different programs, because that's how big these programs or these projects get in the real world. And so we want to name these packages and give them a good explanatory name. So like maybe we might have the write process. We might call that package write process. We might call the call it the calculate package. So we know kind of what those packages, what all of those programs do inside of that package. And again, the packages are more for organizing. So we call it hello, and I just click finish. So now I have my SRC, I have my hello. Now programs are all stored in a class file. So I'm going to do a right click on the package, hello, I'm going to point to new, and I'm going to come down here and I'm going to click on class. Now, the class name has the same exact rules as the project. Same exact. The first letter, the first character has to be a letter. Everything else can be a number, letter, or underscore. No spaces. So I'm going to call this, I can give the same exact name to the package. It's not going to hurt anything. I'm going to call it hello world. Now, since we're in a test environment, we're going to need this thing called public static void main, and that will be explained in detail as we get through chapter 2. So I'm going to check that box, and I'm going to click finish. And when I do, it automatically creates the class file. I now have hello world.java. That's the class file. And up here it says, hey, we're inside the package hello. The name of this class is public class hello world. And I have this open brace, and down here I have a closing brace. If I click in front of that brace, it will show me the matching closing brace. Okay. Here's that public static void main. Now, we have two things inside of our programs. We have methods and we have variables. Methods do something. They actually execute and do something. Variables hold data. So in this particular case, we have public static void main. Main is a method. It's going to do something. Since we're in a test environment, the public static void main is executable. When I run this, it says I'm looking for either some starting process or I'm looking for a public static void main. And so since it finds a public static void main, it is now executable. Don't worry about these string args. We can actually run this from a command prompt, and I can actually put in parameters in that command prompt, and they will be brought into here. For the most part, I should say, yeah, for this class, we're not going to be using these strings args at all. Okay, so now I need to put in a line of code. And the line of code we're going to use is called a system, uppercase S, system dot well, I want to make this easier on us. What's nice is I can do an SYSO. I'm going to hold down the control key and I'm going to hit the space bar, and it automatically should bring up, try it again. SYS, it screwed up because I already started typing something. SYSO, control space, and there's my sysout print. So that's already highlighted. All I have to do is hit the enter key and it automatically prints system.out.println. Now we're going to go into a lot of details of what these do, but for right now we're just doing this. I'm showing you how to create a project. So you're going to need to do that for homework assignments. So inside the parentheses, I'm going to type a double quote, and I'm going to type hello space world. So now when this program executes, it's either going to look for a starting point for this particular program or a public static void main. Here's our public static void. It's going to execute that, and it's going to execute the system.out.println hello world. Now, I go ahead and come up here and click. Now I've got a save and a save all. I always click the save all in case I've changed multiple class files. So I click save all. And then over here I've got this green ball with a triangle in it, and if I point to it, it says run. And when we click it, down here in this thing called the console, it says hello world. So we just executed our very first program called hello world. Okay? So the whole point of this is how to basically create a project from scratch. So now let's get back to the book. So the book basically says a Java program has parts that serve specific purposes. So we're going to open up this thing called simple.java, and it's going to pretty much be exactly what we just covered here. So I'm going to expand chapter 2, expand the SRC, expand chap 2, and I'll come down here to simple.java, and here we have package chap 2, public class simple, public static void main, and then system.out.println, programming is great fun. And again, when we run it, click the green ball of the triangle, it prints programming is great fun. So system.out.println will print into this console area. Okay? Public is a Java keyword and must be written in all lower cases. It is known as an access specifier and controls where the class may be accessed from. Public specifier means that this class is unrestricted. And basically what that means is any program inside of this project can call this class. Class, which is also written in all lowercase, is a Java keyword and must indicate the beginning of a class definition. A class is basically a program. Simple is the class name, and the name is made up by the programmer. Now again, as a programmer, we come up with the class name, and again, make sure you give a good descriptive name of what this class is going to do. Okay? Maybe we might write a program that calculates the state tax. We would call this calc state tax. The class could have been called pizza or dog or anything the programmer wanted. You can create more than one class in a file, but you can only have one public class per Java file. So again, that's a chapter. I believe that would be covered in, I think, Java 2, if you take the Java 2, the second class. So basically we have our brace, and again, the brace says this brace and this brace says this is the beginning of the class, and this is the end of the class. Now, inside of our public static void main, it has a brace as well. It has an open brace, says this is the opening of this method, and this is the close of that method. So make sure you have a closing brace for every open brace in your program. So this one here says public static void main. This is known as the method header. Marks the beginning of the method. I already talked about that. Okay, let's move on. I think I've talked about this. Okay. Just realize Java is a case-sensitive language. If you use an uppercase A and then you try to use that same name with a lowercase a, it will error out because it basically knows that there's a big difference between an uppercase A and a lowercase a. Okay. Special characters. A double slash is the beginning of a comment. Left and right parentheses are the opening and closing parentheses. We'll use this in the method header. The open brace and closing brace, this is basically the contents of a class or a method. Double quotes encloses a string of characters, such as a message to be printed on the screen. And a semicolon, very, very important, marks the end of a complete programming statement. So right here we saw system.out println, programming is great fun, and semicolon at the end that says that's the end of that command statement, that programming statement. Okay. Now, let's talk about the print and the println methods. Okay. The print and println methods are used to display text output. They're part of the Java API, which is a collection of pre-written classes and methods for performing operations. So we have the system. That's a class. That's a class that's in that JRE system library. That's part of that. We have direct access to it. We don't have to do anything. We don't have to, remember I talked about the import. We don't have to import anything. All we have to do is use the system. The out is a member of the system class. That's an object. The print is a method of the object, of the out object, and the println is a method of the out object. Now, what's the difference between them? Well, here's the difference. So let's look at two lines. This is a println method. So I look at two lines. So here's println. It says programming is great fun. I can't get enough of it. When we run it, you'll notice it says programming is great fun. I can't get enough of it. Now, one thing I want you to pay close attention to, I can actually click below that. Because here's what a println does. A println says, print this and automatically drop down to the next line. So it's kind of like using a word processor where I'm typing and I hit the enter key at the end of the line so it automatically goes down to the next line. That's what a println does. It prints and drops down to the next line. That's why I can click below it. So now, let's look at the print method. Let's look at great fun. So I open up great fun, and here I have the same exact thing where it says programming is great fun. But notice it says programming is space and then great fun. This is a print. This is a println. What the print statement does is it prints and it stays on that same line. So now when I print great fun, it's going to continue on that line. And since that's a println, it automatically drops down to the next line. So when we run it, look what happens. Programming is space and then great fun. Since it's a print, it didn't automatically drop to the next line. Since that's a println, look, I can click below it. Now, one thing I want to kind of show you is I'm going to get rid of this ln right here. And now when I run it, notice I can't click to below it. Where's the insertion point? It's sitting right there at the end because it printed programming is, stayed on the same line. It printed great fun exclamation point and stayed on the same line. So this can be dangerous because if I did a print and I tried to do another print somewhere else in my program, it's going to print it on the same line because my insertion point is sitting at the end of that line. So just be aware of the difference between a print and a println. Now let's look at unruly. So notice I've got print. These are our top sellers. Print, computer games, print, coffee, println, aspirin. Now watch what happens when we run it. Oh. Well, I don't know what's going on there. Let's see. Huh. For some reason that program had error in it. Okay, so I print. These are top sellers. Print computer games, print coffee, print LN. So notice these are prints. Remember what's going to happen when I do a print? Well, when I run it, these are our top sellers. Computer games, coffee. Notice there's no spacing in there. So how do we fix this? Well, we're going to use the adjusted program. And it basically now has print. These are our top sellers. /n/n. What does that do? Watch what happens when we run it. These are our top sellers. Computer games, coffee, and aspirin. Wow. Notice I got a /n there, I got a /n there, and I got a /n there. What does that do? Well, these are called escape sequences. And what those do is no matter where they're at, even though they're inside of double quotes, if I have a /n, that automatically creates a new line. A /t will create a tab. It's like hitting the tab key on your keyboard. A /b is a backspace, and a /r will go back to the beginning of the current line. Now realize the /b and the /r are only used for printing. If I actually print this out on paper, it will not do it on the screen. If, let's say I needed to print a backslash, well, if I put a // inside of my double quotes, it will print one backslash. If I needed to print a single quote, I could do / single quote, and that will actually print a single quote. Same way with the double quote, if I wanted to put double quotes in there. So let's say, for example, I wanted to put double quotes around computer games. Well, I have to do a / double quote, and then / double quote. And now when I run it, we'll see that there's double quotes around computer games. Because if I just use a double quote, there's already double quotes there. That says I'm going to actually print whatever's between these double quotes. And so I can't just use a double quote by itself. If I need to print a double quote, I have to use a / double quote. There's a /n will automatically go to a new line, and /n will go to a new line. Okay. So we actually skipped a program up here. Yeah. So now let's look at this one here. This is kind of cool. It's called tabs. So let's look at tabs. And it says these are our top sellers, /n, then /t computer games, /n goes to a new line, and /t, which is a tab, coffee, then /n at the new line /t. So let's see what that does. It's going to put a tab in front of each one. So now when I run it, look at that. These are our top sellers, tab computer games, tab coffee, tab aspirin. So really, we can really get very organized on our printing of things and how they look on the screen. Yeah, you might want to dog-ear this, put a little bookmark on this page, because this is kind of a nice page to kind of refer back to when you want to use one of these escape sequences. Okay, so let's talk about variables and literals. So variable, let's open up the variable program. So variable.java. So here I have public static void main, so that's the executable part of the program. I have int value. This is called a variable. A variable holds data. What type of data is going to be put in here depends on this statement right here. Now notice the reserved words all have orange. So the orange basically says that is a reserved word. Now what int stands for is integer, and I'm going to talk about data types here in just a second. And so this says only an integer can go into this value. Then I come down here and say value is equal to 5. So now, right now up here on line 9, when I say int value, nothing is in there. It's called a null value. That's a hexadecimal 00, which is nothing. When I come down here to line 11, now I put the number 5 inside of that variable called value. And now I come down here and say print, the value is space. Since it's a print, it's going to stay on the same line. And then down here I say print ln value. So it's going to print whatever's inside of value and then automatically go down to a new line because of the ln. So We run it, and it says the value is 5, and if I click below it, I can see, yes, the println automatically went to the next line, to a new line. Now variable 2, let's take a look at that. Now this is going to cause an error. So I look at variable 2, and this guy says int value, and then value equals 5, and so everything's the same all the way up to line 12. The only difference now is line 13. It says println double quote value double quote. Now look what it's going to print. The value is value. That becomes what's called a string literal. Anything we double quotes will just literally be printed on the screen. So the whole point of this is to let you know, for variables, we do not put double quotes around them or single quotes. Now another thing I want you to notice is we got a yellow squiggly line underneath the value. Whenever you see a yellow squiggly line, that is called a warning. And if you want to, you can actually hover over that, and it will tell you, remove value in all its assignments. Now, the reason it says you want me to remove it, because it says, guess what? We've declared this variable called value, we've assigned a number to it, and then we don't use it. So this time this yellow squiggly line is saying, this guy's not used anywhere, so it's really not needed, you need to delete it. Now, if you see a red squiggly line, so let's say, for example, I do this. Now I've got a red squiggly line. This is an error. This program will not run because of this red squiggly line. You'll notice here on the left-hand side, I see this light bulb with a red X. I also see a red dash over here. If you see that, that is an error, and we need to fix it. Now, a lot of times, Java will help you fix it. If you hover over that red squiggly line, it says, hey, this is missing a quote. It says insert the missing quote. If I click on it, look what it did. Well, it put it in the wrong spot, but it's basically telling you it needs a double quote, and right here is where it needs it. Well, I put it in, and it basically goes away. Now, if we need, so let's say we have a situation where our string is going to be our text within the double quotes is going to basically scroll, and it's going to go off to the side. Well, it really doesn't hurt anything, but for maintainability, we really need to make sure that we can see everything on the screen. What we can use is this plus sign as a concatenation operator. And this concatenation symbol will basically it glues things together. If we're talking about numbers, it does addition. If they're text or strings or text, it will glue them together. So if I have this is space and then a plus sign, and then it will actually glue these two together into one, and it will look like this is one string. Here I said if I got number equals 5 and sys out the value is plus sign number, it will basically glue that variable, what's inside there, it will basically print the value is 5. Now notice here I've got double quote, enter a value that is greater than 0, and I go to a new line and less than 10. That will give us an error because it basically, this is in two separate strings, and it basically will error out. What I can do instead is enter the value that is, double quote, concatenation symbol, greater than 0 and less than space, ending double quote, plus than 10. I can do it this way as well. Sum is 249, the sum of the three, ending double quote, plus sign, and then double quote, the number is space, double quote, and plus the sum, okay? Now another thing to be careful of is be careful with quotation marks. If we try to do this with this particular program, if I try to put double quotes around 5, it's going to error out. If I hover over that, it's going to say, you need to change the value variable to a string. No, we don't want that. We want to keep it an int. So double quotes are only for text or strings, and we don't use quotes at all for numeric items. So let's talk about literals. So let's take a look at literals.java. So here we have int apples, and then I say apples is equal to 20, and I say today we sold. Now notice the starting and ending double quotes, plus apples plus double quote space bushels of apples. Okay, so when we run this, watch what happens. Today we sold 20 bushels of apples. Okay, so it glued these all together, and it's going to print whatever's inside of apples, which is 20. So today we sold 20 bushels of apples. Identifier is a program-defined name that represents some element of a program. Variable names and class names are examples of identifiers. You may choose your own variable name. Keywords are made up of core language of, Table 1.3 in Chapter 1 and Appendix D, and available on our site. I show a list of Java keywords. Okay. So if you go to the Appendix D at the back of your book, you're going to see these are all reserved words in Java. You cannot use these for any variable names because these all are reserved for Java. Okay. I think that is, yeah. So back to variables and literals. So we already talked about that one. Yeah. Okay, so yeah. Oh, so let's talk about variable names. What's legal, what's not legal. Variable names are kind of like projects and classes. They cannot start with a number. So variables must always start with a letter. Then after that, they can contain a letter, number, or underscore. We cannot use any spaces. We cannot use any special characters. So if we look here, I've got day of week. That's legal. Notice the camel casting. Day and then of is uppercase and week is. Now variable names, it's always customary to make the first letter lowercase. Variable names, the first letter is always lowercase. Now here's an illegal one. I started with a number. That is an error. June 1997, completely legal. Mixture, £3, illegal because of the pound sign. We cannot use any special characters. Week space day, that's illegal because that's going to be considered as two separate variable names. Okay, so if you wanted to do weekday, you would do week, uppercase D, day, weekday. Class names, it's standard to begin variable names with lowercase and to capitalize the first letter of each subsequent to make the name. Yeah, but classes, we always make the first letter of classes uppercase. Okay, now let's talk about, we kind of touched on numeric values. We saw this thing called int. Let's talk about these numeric data types. These are called primitive data types. And primitive data types are numeric data types. And here they are. We have byte, we have short, we have int, long, float, and double. A byte is only 1 byte long, and the lowest number we can put in there is a -128. The highest number we can put in there is a +127. So if you're working with very, very low numbers, we can make it a byte. A short is always 2 bytes long, and it's in the range of -32,768 to a +32,767. We have an int, and ints, I don't care if you've got the number 0 in there, it's always going to take up 4 bytes. As you can see, you're in the billion range, -2.1 billion, all the way up to +2.1 billion. If we need anything larger than a 2.1 billion, we need to use a long then. And longs are basically very, very, look at that. That's 1,000, million, billion, trillion, quadrillion, and quint. Okay, so probably not going to need anything larger than that. And if we do, we use a long. Now, byte, long, short, and ints are all whole numbers. You cannot put a decimal in them. They do not hold decimals. They are whole numbers. If you need decimal places, you're going to use a float or a double. Floats are always 4 bytes. As you can see, there's the range from that to that. Doubles are always 8 bytes, and they're from that range to that range. Okay. Now, for this class, or for, I would say, most Java programming, we're pretty much going to be using ints and doubles. That's all we're going to use. Okay. Now, I think this next example, we're going to show integer data types. So, but we're going to show some different, we're going to show some different primitive data types. So let's look at integer variables. So I've got int checking, byte miles, short minutes, long days. Now notice one thing I want you to point to is we're using comments. And comments are very, very ideal for programs. Now, tell you a little story. When I was first going to college for computer programming, we had a guy named Bill, and Bill was he was just an ideal programmer. And everybody went to Bill for help. And so one day we had to work on a program, and we were kind of comparing. Once we got our homework back and graded, I asked Bill, hey, how many lines of code do you use? He said, I only used 352 lines. How many did you use? I said, gosh, I used almost 1,000 lines of code. And when I looked at his, it used all this slick coding and this, that, and the other, and it was very hard to read. Now, my program wasn't ideal. I mean, it was just pretty run-of-the-mill program. But one thing I did use is I made sure I used good variable names. I used comments. And what these comments do is tell the programmer that's coming behind you when you're working on this code what you were trying to accomplish. That way there, it makes it easier for that person to basically maintain this code and make those changes that are needed. If I have to spend a day trying to figure out what this program's doing before I can make my changes, I've wasted a day. But if somebody commented this program well, and it takes me about an hour to figure out what's going on, then that is time saved, and it basically saves a lot. So the ideal thing is to put comments in your code when you're writing a program to let the person know behind you what you are doing. So that's basically what these comments are doing. So anytime there's a // everything behind that, the compiler will ignore. Let's talk about that for a quick second. I don't think I touched on that. When you run the program, here's what happens. A compiler goes in and converts all of this English into machine language. Now, machine language we cannot read. Okay, so let me show you what I mean by that. When we first opened our Java program, or Eclipse, we had to pick a workspace. And what is your workspace? That's where all this code is stored. Now, where is that workspace? Well, if I click File and click on Switch Workplace and click Other, this is where my workspace is. So I can do a right click on that and click Copy. And then I'm going to go to Windows Explorer. I'm going to paste that up here on the top. I'm going to hit the Enter key. So now I'm in my workspace. So here I am in Chapter 2. So when I double click on Chapter 2 and go in there, notice that I have an SRC folder. So I double click on that, and there's my Chap 2 package. Again, package is just a folder. Double click on that, and look, here's all those Java programs. Okay. So I can actually go in here, and if I try to edit this file, it's going to change the file we're currently in. But the one thing I want you to look at is I'm going to come back over here. Notice I got this bin folder. I'm going to double click on that, and here's my Chapter 2 package, and double click on that. And now I have a class file. So whenever the compiler runs, it converts it into machine language, which is called the class file. Now, if I were to open up, so let's say I've got this, like here's unruly. If I do a right click on unruly, I'm going to say open with And I'm going to say, I'm going to open it with Notepad. I want you to look at it. And that is, you're going to see some English in there, but for the most part, you're going to see a lot of gobbledygook. That is machine language. Only the computer that's running this program understands machine language. Now, for the most part, what happens, it doesn't matter what language you're using, whether you're using Python or whether you're using COBOL or C++ or C Sharp or Java or whatever the case may be. Once it's in machine language, the computer running this doesn't care. All it knows is it's in machine language. So basically that's what a compiler does. It puts it in machine language so the computer can run it. Okay. What we're utilizing, so what's nice about that is this. As a computer programmer, I can write a program, then I can put that class file out there for people to use and run. They can't modify my code. They don't. So that's how folks can charge money for a program, is they cannot take that machine language and basically go back and see what it does. Only the compiler can do that. So that's what's nice. So that's kind of what's going on there. Okay, so back to this program. So I've got int checking, byte miles, short minutes, and long days. I make checking equal to -20, miles equal to 105, minutes equal to 120, and days equal to 185,000. And then I got println. We made the journey of miles. Okay, so we're going to, whatever's in miles, and then the actual text miles. It took us minutes. Our account balance is $checking. About days ago, Columbus stood in this spot. So when I run it, notice these are all println, so they're going to be on separate lines, because every time it prints, it goes down to a new line. And I run it, and it says we have made the journey of 105 miles. It took us 120 minutes. Our account balance is $-20, and about 185,000 days ago, Columbus stood on this spot. So, pretty cool. So those are the different primitive data types that we can utilize. Okay. Now we got floating point data types, which is the float and the double. So let's take a look at that, which is the sale.java. So let's take a look at sale.java. And there we have double, price, tax, and total. Now look what they did here. Instead of having three separate lines that said double price, double tax, and double total, we can actually do it on one line by just saying double price, comma, tax, comma, total. So I can actually declare three variables on one line. Then I say price is equal to 29.75, tax is 1.76, total is 31.51, and then I can say the price of the item is, again, this is ln, the price of the item is price, the tax is concatenation symbol tax, the total is concatenation symbol total. And again, when we run it, the price of the item is 29.75, the tax is 1.76, and the total is 31.51. Again, notice that we used a double. So that will accept decimal places. I don't want to get too much into this because I guess if you have really, really super large numbers, you're going to need what's called the scientific and E notation. So if I were to, so 4.728917197 times 10 to the fourth power, that basically will make this 4.728197 E4, which is an exponent 4. And so we can see what those numbers are. So let's look at sun facts. Again, they touch on this, but just realize, if you really need large numbers, you'll need to utilize this. But yeah, we can actually use the scientific notations so it's a double distance and mass, and distance is equal to 1.495979 E11, and mass is equal to 1.989 E30. And when we basically say the sun is distance, meters away, and the sun's mass is mass, kilograms, it's going to print those E notations. So it's going to basically print them on their face value. Okay, now the next primitive data type is this thing called Boolean. And Boolean is named after a guy named Boolean. His last name was Boolean, and he developed this whole thing called Boolean algebra, where we basically have all of these true, falses, and all these different things going on. So let's open up the trueFalse.java. And notice I've got Boolean. No, it's in orange, so that is a reserved word. And I've got bool. That's my variable name. And I say bool equals true. I'm going to go ahead and print bool. Then I'm going to say bool equals false. I'm going to print bool. And when I run it, it basically says true and false. Okay. Now, one thing you should ask is, well, how can this be numeric? It's a primitive data type. All primitive data types are numeric, but it prints true and false. Really, behind the scenes, true is 0 and false is 1. So that's really what is being printed here is 0 and 1. But the compiler sees it as true false, so it actually prints true or false. Notice if I tried to put a capital T in there, it would basically error out. It basically says that's not a reserved word, because notice that the lowercase t and true and false are both orange. Those are reserved words. We also have the char data type. That again, this is a primitive data type, and you're going to basically go, whoa, 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 whoa. This seems kind of weird because we're talking about letters, but you're saying they're numeric. Well, let's look at letters.java. And there I've got char letter. And it says letter equals, now with chars, if I tried to put a double quote around this, I'm going to get an error. And when I hover over it, it says change the type of letter to string. For strings, we use double quotes. For chars, we always use single quotes. So when it says letter equals single pick A, single pick, and we're going to print letter. And if I print letter, single pick B, single quote, and then I print letter, let's see what prints. So when we run it, it prints A and B. Okay, so what's going on here? Well, let's do this. Let's take a look at the next program of letters 2. So let's open up letters 2, and here I print letter. So I've still got char letter. This time I say letter is equal to 65. I print the letter, and then I say letter is 66, and I print letter. Well, let's run it and see what we get. I get A and B. How does that work? Well, if you were basically some kind of a system administrator, IBM has this book called the Yellow Card. And as a system administrator, we live and breathe out of this book. And one of the things we can look at is towards the back is we have fixed storage locations. I don't know if you can see that. But in there, I can look, and I can look up the hexadecimal variations, and there's 256 different variations, 0 through 255. And so if I look, so if I were to look, if I can find it, it's here somewhere. I know it's here. Anyways, I look up the capital letter A, and if I look, it has a hexadecimal representation of 65. If I look up a capital letter B, it has it shows the 66 as its hexadecimal representation. So the 255 characters. So what are they? I can usually find it pretty quickly. Here we go. There we go. So capital letter A is 65, capital letter B is 66. If I come down here, a lowercase a is a hexadecimal 61, and a lowercase b is a hexadecimal 97, and a lowercase b is a hexadecimal 98. So two separate. I can see that a return character, a new line character, is a, let's see, new line. Yeah, I can't seem to find it. I know it's here somewhere. But anyways, that has its own hexadecimal representation, something known as Unicode. Okay, if we go back to the book, it's called Unicode. Your characters are internally represented by numbers. Each printable character, as well as many non-printable characters, are assigned a unique number. Java uses Unicode, which is a set of numbers that are used as codes for representing characters. So chars are basic, they're always numerics. Even though I put in a single character surrounded by a single quote, that is a numeric value to Java. Yeah, B is a 67. Or I'm sorry, C is a 67. So now, let's take a look at this initialize.java. So initialize.java. I have my public static void main, and this time I'm saying month, int month equals 2, comma, days equals 28. So not only am I declaring a variable, but I'm assigning it a numeric value at the same time. And we can do that with this initialize. Okay? So instead of saying int month, int days, and then say month equals 2 and days equals 28, I can do it in one line, creating two integer variables, month equals 2, days equals 28. Then I can come down and print those. Month, and then concatenate the variable month, has the variable days and the text days. And so when I run it, month 2 has 28 days. Okay? So not only can I create a variable, I can initialize it as well. Now variables can only hold one value at a time. So when I assign a value, so if int x equals 5 and I print x, then I can say x equals 99 and I can print it again. So I can actually, that variable can change what's inside of it, what's currently holding. Okay, now, so we've got these primitive values. What can we do with them? Well, we can do arithmetic on them. So how do we do that? Well, I can do addition, subtraction, multiplication, which is an asterisk, division, which is a /, not a backslash, and I can do this thing called modulus. So if I take a number and divide by another number, there could be a remainder, and that's what modulus will give us, is the remainder. So if I can say amount equals 4 plus 8, I can say total equals price plus tax. I can say number equals number plus 1. Now look at this one. Number equals number plus 1. That the first thing it does is it does everything on the right-hand side of the equal sign. So it adds 1 to number, and then it puts it back into number. Okay? Markup equals 12 times 0.25. Markup better be a double. Commission equals sales times percent, so on and so forth. So let's take a look at wages. So wages.java, I open up that, and it says, so here's my public static void main, here's my class wages. Here I've got 1, 2, 3, 4, 5, 6, 7 different variables. I've got regular wages, I've got base pay, I go ahead and assign that to 25. I've got regular hours, I assign that to 40. I've got overtime wages, I've got overtime pay, and I assign that to 37.5. I've got overtime hours, I assign that to 10, and I've got total wages. I say regular wages is equal to base pay times regular hours. So right now, regular wages has a null value in it. So it's going to do everything on the right-hand side of the equal sign. So it's going to take base pay times regular hours, and then it puts it into regular wages. Overtime wages is equal to overtime pay times overtime hours. So it takes overtime pay, multiplies overtime hours, then puts it into overtime wages. Then it takes regular wages and overtime wages and adds those two together and puts it into total wages. And then it says the wages for this week are $ concatenate total wages. We run it and we get wages for this week are $1,375.00. So we can do arithmetic. Now, integer division. We have to be very, very careful with this, because when you divide two integers, most likely you're going to get a double, a decimal place. So that's why whenever we do integer division, we basically have to always make sure that we put that into a double. So right here, if I've got double number and number is equal to 5 divided by 2, well, you're going to get a decimal place. So operation precedence, or what was known as the order of operation, we have to realize what's going to happen first. For example, 12 plus 6 divided by 3. It's going to do the division first before it does the addition. So just realize the order of operation. Again, it's going to do any negation, what's called urinary negation. It's going to do that first. Then it's going to do any multiplication, division, or modulus, whatever comes first. And then it's going to do any addition or subtraction, whatever comes first. So basically in this situation here, it's going to do 2 times 4, which is 8, plus 5 is 13. Here it's going to do 10 divided by 2. It's going to do that first, which is 5, minus 3 is 2. Here you got 12 times, it's going to do 12 times 2 first, which is 24. Then it's going to add 8 to it, which is 28, 32, minus 4 is 28. Then the same thing with this one here. So 17 divided by 2 is, was that 7.5? Well, the 0.5 is now, so 5 is basically the modulus. So 4 plus 5 is 9, minus 1 is, okay, anyways, 0.5. Yeah, anyways. So just realize what's going to happen there, and then you can group with parentheses as well. Okay, now, these endless spotlights are really kind of cool because they set up a situation, and then you basically, they say, okay, write the code for it. So we need to determine percentages as a common calculation in computer programming. Although the percent symbol is used in general mathematics to indicate a percentage, most programming indicates, including Java, do not use the percent symbol for this purpose, and the symbol for this purpose. In a program, you have to convert a percentage to a floating decimal point, just as you would if you're using a calculator. For example, 50% would be written as 0.5, and 2% would be written as 0.02. So let's suppose we earn $6,000 per month, and we're allowed to contribute a portion of our gross monthly pay to the retirement plan. So we want to determine the amount of the pay will go to the plan, whether it's 5%, 8%, or 10%. But we don't know how much it's going to be, so what we can afford. So we're going to write a program to determine whether or to see what we can afford. So we're going to open up the contribution.java. So again, let's say we make $6,000 a month. What can we afford if we either want to put 5%, 8%, or 10% towards our retirement plan? So what can we afford? So what we're going to do, we got monthly pay, and then we got contribution. I say contribution is equal to monthly pay times 0.05, which is 5%. Contribution is equal to monthly pay times 0.08, which is 8%. and then contribution equal monthly pay times 0.1, which is 10%. And we're going to print each one of those with the print ln. Okay, 5% is $ contribution per month. We're going to do that for each one. So when it runs, now we can see what can we afford. Can we afford $300 a month for 5%, or $480 per month at 8%, or $600 a month for 10%? Okay. We also have this. Let's take a look at this next one. It says, okay, another common calculation to determine percentage discount. For example, suppose a retail business sells an item that is regularly priced $59 and is planning to have a sale where the item's price is reduced by 20%. You have to been asked to write a program that calculates the sale price of the item. So first we need to get the amount of the discount, which is 20% of the item's regular price. Then we need to subtract that discount from the regular price, and that gives us the sale price. So let's take a look at discount.java. So here we have double regular price equals 59.0. We got another double discount, double sale price. Now I see a squiggle line underneath sale price. That tells me that we're not going to be utilizing that. Huh. Are we? Apparently not. Huh, that's weird. And then I got double exponent and double squared. So the exponent is math. Now, here's a cool thing that we basically can utilize is we've got this math class out there. Now, if I type a period behind math, you can see that there is a whole bunch of methods that we can utilize. Now, one thing I haven't really talked about, is the Java Bible. If you go out here to Google Classroom, I have a link to it out here. It's called the Java API or the Java Bible. If we click on it, it takes us out to the folks who basically maintain the Java code. They basically have it out there. So here's all the different packages that come with Java. Now again, all of this stuff is stored here in this JRE system library. So when I go back to it, here's all the different classes we have access to. Now some classes are automatically brought in, so we can use them right out of the box, and others we have to import in. So if I come down here to the IMS, here is the math class, and if I click on it, it basically tells us how we can use this class. And it's going to tell, here's all the different methods we have access to. We've got ABS, ACOS, add extract. So here's a whole, and this is pre-written code. All we got to do is give it some variables, and it will actually do that calculation and give it back to us. So the one that we're using here is .pow, and what that is the power. So I put regular price in here, and then I can actually increase it by the power of 3. Okay, I put that into exponent, and then I've got system.out exponent, and here's the square root. I can actually take the regular price and do the square root. I think this is done as an example. Okay, so we can do an example. So these are not used in a calculation. They're just trying to show you how we can use the math class and different variations. Okay, so that we'll cover that in just a sec. We'll see what comes out of that. So our discount is regular price times 0.02. So we got the discount, and then I can say sell price equals regular price minus the discount. So I'm going to do this. I'm going to change that to sale price, and I'm going to get rid of it. This. There we go. One more. Yep. There we go. So I think this is what's in the book. So I calculate the sale price as the regular price minus the discount. Then I print the regular price, $regular price. The discount amount is, and I can actually get rid of this and just put the discount. And I can say the discount amount is $discount, and then the sell price is $sell price. Now, I'm going to comment these guys out for now. So when I run it, it basically says the regular price is $59. The discount amount is 11.8, and the sell price is 47.2. Well, again, let's show what we can do with these let's see what we can do. And then let's show how these work. Again, these are all built into the math class, so I can see what the exponent is if I take the regular price and raise it to the third power, or what's the square root of the regular price. So now when I run it, I can see that the exponent, if I take the regular price of 59 and take it 59 times 59 times 59, I get 205,379.0. The square root of 59 is 7.68, and that big long number there. So again, that's basically available to us through the math class. Okay. Yeah, and that's basically kind of what we just talked about right there. There's the power and there's the square root. Okay, now combined assignment operators. A combined assignment operators combine the assignment operator with the arithmetic operator. Quite often programs have assignment statements in the form of like x equals x plus 1, or balance equals balance plus deposit. Remember, everything on the right-hand side of the equal sign gets done first, then it puts it into the variable on the left side. So I can say balance equals balance minus withdrawal. So x equals x plus 4 adds 4 to x. X equals x minus 3 subtracts 3 from x. X equals x times 10 multiplies x by 10. X equals x divided by 2 divides x by 2. X equals x modulus 4 assigns the remainder of x to 4. Now, what we can do, instead of doing all of these things, we have these things that are called the combined assignment operator. I have the plus equal, minus equal, asterisk equal, slash equal, and percent sign equal. So that's actually multiplication equal, division equal, and modulus equal. So instead of saying balance equals balance plus deposit, I can just do balance plus equal deposit. What it says is take what's over on the right-hand side and add it to the left-hand side. If I said balance equals balance minus withdrawal, I can actually say balance minus equal withdrawal. And it says take whatever's on the right-hand side and subtract it from the left-hand side. So those are the combined assignment operators. Now, conversion between primitive data types. So Java is what's called a strongly typed language. That means before a value is assigned to a variable, Java checks the data types of the variables and the value being assigned to determine whether they are compatible. So if I've got int x and I've got double y, and y is equal to 2.5, and now I say x equals y, guess what's going to happen? It's going to truncate off the 0.5. The assignment statement is attempting to store the 2.5 in the int. The Java compiler enters this line of code and responds with the error message, possible loss of precision. Okay, so it's basically saying, guess what? I can't do that. So what I want you to think about is I want you to think about the child's thing where you put round pegs and round holes, and square pegs and square holes, and so on and so forth. I want you to think of a peg with a big hole, okay? And think of that as as like a double. So the double is the largest hole we can get. I can put a byte in there, I can put a short in there, I can put an int, a long, so on and so forth. Okay, that will hold anything. And a float can hold everything up to, so what they're trying to show here is I can put a byte and a short and all these other ones. I can put a short and an int, a long, a double, a float, and a double. I can try to put a short and a byte, but it could give me an error. So vice versa. An int goes into a long, a float, and a double, but it's going to be, it could cause errors most likely if I try to put an int and a short and a byte, or a long and an int and a short and a byte. Okay, so basically what we're saying is it's easier to put this number in the ones above it than below it. We should always try to just always put a double and a double and an int and an int, so on and so forth. Now we can do what's called casting. I can convert a number into a different primitive type before I put it in there. So let's say x is an integer and number is a double, or maybe it's a long. Well, if I put this left paren, int, right paren in front of the number, it converts this into an int before it puts it into x. Now again, we have to remember this situation here as far as putting an int into a short or a long into an int. Most likely we could get truncated. We could truncate numbers. So be aware of that. So if I have a little num, which is a short, and I've got a big number and I'm going to convert it to a short, it's going to actually convert big num to a short and then put it into little num. So is casting good? I'm going to say most of the time probably not, unless this x is a smaller number. Let's say x is a long. I'm going to convert it to a float and put it into value. That's probably okay. So it says the cast operator can be applied to an entire expression and close in parentheses. For example, I can say pies per person equals double. And notice I got pies divided by people. That's going to be converted to a double and then put in. So we can do that. But again, casting can cause issues. Mixed integer operations. So if I try to basically have shorts, and I'm going to try to put them in integers. And again, it's best to always do ints to ints, doubles to doubles, longs to longs, so on and so forth. Yeah. Creating a name constant with final. So let's say we have a situation where I have a percentage that I want to utilize for a specific number. So in this case, it's 0.069. So I'm going to take the amount is equal to balance times 0.069. Now, if I use this 0.069s in multiple places all within my program, it can, let's say down the road, I want to change it to 0.72. So 0.072. Well, I might find, let's say I've got it in 5 different spots. I change it in 4, but I forget that 5th spot. Well, that can cause issues. So what we want to utilize instead is something called a constant. So the way we declare a constant is, let's just go ahead and open up. No, we don't have, I guess we don't have that. Okay. So the way we create a constant, we use the word final. So final says this is a constant. It can never, ever, ever change. But another rule to a constant is it must be assigned a value. So I got final double interest rate is equal to 0.069. Now another rule for it, and it's more, we don't have to do this, but it's highly suggested we do, is constants are always uppercase. That way, if we ever see a variable within our program and it's all uppercase, that tells us that that is a constant. Okay? So if I'm going through a program and it's a very large program, when I see something all uppercase, that tells me that is a constant. So I come down here and I've got amount equals balance times 0.069, or I can say amount equals balance times interest rate. And that tells me that that is a constant. Now, if I ever have to update that, so that this, again, if this interest rate is used in 5 different spots within a code, now all I got to do is come up here and change it in one place, and that will change it in every place I'm using that interest rate. Here's another constant that's built into the math class. It's the PI class, or pi. And pi is 3.14159, that big long number. So if I need to do the area of a circle, I just do area equals math.pi times radius times radius. So Again, you'll notice the PI is all uppercase. That is a good indicator that that is a constant. Now we got string class. So the string class, we talked about primitive data types, and primitives are just numerics. So when I create an integer data type, that is basically a container that will only allow integer data types. Okay? What if I need textual stuff? Well, that's a string, and we're going to use the string class. Now, a class, like we've seen so far, a class has a whole lot of stuff in it. In fact, if I come out here to the Java API, and I come down here to the string, here's the string class. I click on it, and man, there is a whole lot of stuff that comes with it. Look at all these methods that come with it. Char at, code point at. So there's a whole bunch, look at that, pages and pages of stuff that comes with it. Okay? So what we need to do is realize that there's a lot of stuff that comes with the class. With the primitive data type, that's it. Just the value of that number is all you get. So objects are created from classes. So we got the string class. It says the class that is provided by the Java API for handling strings is named string. The first step in using a string class is not to declare a variable, but here it is, we say string. Now notice classes are uppercase letter. The first is uppercase. So it's uppercase S string. And then I'm going to create a object variable named name. Primitive data type variables and class data type variables. A variable of any type can be associated to an item of data. Primitive data type variables hold an actual data item. And it says the class data type variable does not hold the actual data item it is associated with it, but holds a memory address of that item. So if I create a number and I put 25 in it, that's what's inside of it. If I create a name object from a string, it actually puts the address of that object in there, because that object holds a lot of stuff. So to create a string object, I'll say string name equals Joe Mahoney, and I put double quotes around it. So let's look at the string demo. So here I have my public static void main. I got string greeting equals good morning, comma, space, and string name equals Herman. Then I do a sys out println greeting plus name. And look what happens when you do that. Boom, good morning, comma, Herman. Remember, there's a comma space right there. So just type a string. Notice that classes are a little different. Classes always have a blue text, blue color, and again, the first letter is uppercase. That tells us that is a class. Just like system. System is also a class. Now, let's talk about some of the methods that are inside of the string class. So let's open up this string length.java. And let's look. I've got string name equals Herman and int string size. And I do string size equals, now the string size is an integer. Now look at this. I got name dot. If I type a period behind the name, look at all the stuff that's here. It's basically everything that we see here. All of these things are now behind that period when I type a period behind the name string object. Okay? One of those methods is length, and what it's going to do is it's going to count the number of characters in this string name and basically return it as an integer and put it into string size. So now I can say name, that's the name object, has string size characters. So when I run it, Herman has 6 characters. Now what if I add an S to the end? I'm going to add an S to the end of Herman, and guess what it does? Herman's has 7 characters. So it automatically does that. So it has a method built in that will count the number of characters in this name string object. Now here's some other methods that we'll be utilizing that are in the string class. We've got char at, and we basically then put an index number inside the parentheses, and it will give us the character at that position. Length, we covered that. To lowercase, we can actually take all of the items of that string and make them lowercase, or we can make them uppercase. So to lowercase and to uppercase. So let's look at string methods.java. And here I've got string message equals Java is great fun. String upper equals message, there's a message string object, dot to uppercase. And string lower is equal to message dot to lowercase. So those are methods. Now one thing you always know about methods is methods always have parentheses. That's one indicator of we know that it's a method. It has parentheses. Now those parentheses allow us to pass arguments to that method. Now this particular method doesn't require an argument, so we leave those empty. And then I say char letter, so I'm creating a char variable is equal to message.char@2. So it's going to grab the character in position 2 and put it into this letter variable. Now, everyone's going to think that it's the A in Java. That's wrong, because Java always starts with 0. So the very first position is 0, the second position is 1, the third position is 2. So the letter that's going to be put in the char letter is going to be the V in Java. And then I've got int string size equals message.length. We saw that in the last program. It's going to basically count everything in here. That includes spaces, and it's going to put that into string size. And then we're going to print message, upper, lower, letter, and string size. So when it runs, there is Java is great fun. Java is great fun, all uppercase. Java is great fun, all lowercase. There's the V, that's the second position, so 0, 1, 2. And then basically it says there's 18 characters in Java is great fun, exclamation point. Okay, let's talk about scope. Let's open up scope, and I'm going to make it look like it does in the book. So if we look at this, I got system.out.println value, and then it says int value equals 100. Well, why is this red squiggly line underneath value? Because it says, guess what? I don't know what value is. So the scope says we cannot use a variable until it's declared. I need to put this line in front of that line in order to be able to use the value. So just realize we cannot use a variable until it's been declared. So that's the scope of that variable is basically determines on whether we can utilize it or not. Okay, let's talk about comments. Comments are really cool, and we've seen, I've talked about them briefly, but we have different types of comments that we can utilize. So let's open up comment 1. At comment 1, here we see double quote program. Okay, so we tell about the program up here, and down here we basically have comments telling about each of the variables. And then we got a comment saying this is the remainder of the program. Well, let's open up comment 2. And this one here, this is a different kind of comment. All we have to use is a slash asterisk as the beginning, and an asterisk slash, that's the end, and everything in between a slash asterisk and an asterisk slash is a comment. So this allows us to basically put a whole bunch of lines without putting a bunch of 2 slashes in front of it. So that is I believe, let's see, that's called a multi-line comment. So it basically says right there, a / asterisk followed with a asterisk slash. Anything between those will be considered a comment. Okay, we can do comments this way, where I can actually do it like that, or I can actually put dotted lines. So these are all different ways we can do that. Now, The last type of commenting is called a documenting commenting. And basically, let's take a look at comment 3. Now this one has a slash asterisk asterisk, and it ends with an asterisk slash. And here I've got slash asterisk asterisk and then asterisk slash. And I can put things like, well, let's talk about this first though. So how does this work? It looks just like a regular comment. Well, when we use a slash asterisk asterisk, it says that is a documenting one. There is a program that comes with Java called Java.doc. And so how this works is I can click on this project up here, and I can click Generate Java.doc, and I'm going to select this Java2, and I'm going to click Finish. And it's actually running this Java.doc program that's part of Java, and I think it's done. Yeah. So it's got 3 warnings for something. Now, where is that? Well, I have to go to the workspace. I talked about how to get there earlier. So I go to my workspace, I go to Chapter 2, and now I see a doc folder. That got created from this Java doc. When I double click on it, I can actually double click on this index.html, and it actually created, does this look familiar? This looks just like the Java API. And I can click on Package, and there it comes up and it says comment 3 is the name of the class, and it says this class creates a program that calculates a company payroll. If I click on that, it actually comes up and says, hey, here's the methods, here's my static void main, and it says the main method is the program starting point. So if we look, this class creates a program that calculates a company payroll. Come back over here, look at this class creates a program that calculates a company payroll. We go back over here inside of the class comment 3. This main method is the program starting point. Go back over here and look. This main method is a program starting point. Pretty cool stuff. So what's great about that is we can put all this stuff in our code, and then it's self-documenting. And we can take that and save that as part of the program's documentation, and then when somebody comes in to maintain this code, they will go to that documentation. It helps them understand what this program is doing a lot better. Yeah, and they're actually telling it. Some things that I don't know if the book goes into this, but I can actually do an @author, and I'll say Mark Webb. And I can do an @. So if I do an @ here, let's see what was in here. Let's see. Let's do category. And I'll do I'll just do employee. And then I'm going to save this. I'm going to run that Java doc again. I'll do finish. Now I got 1 error and 5 warnings. That's fine. So I'm going to come back over here and I'm going to double click on that. I'm just going to refresh this to see if it works. So there's my package. This class creates a program that calculates a company payroll. And when I go into it, notice now I now have, where was it? Was it here? Shoot, it should be putting that in here somewhere. Use. Maybe it didn't. Maybe it didn't run. Maybe that's where the error comes from. Anyways, it should put author Mark Webb, and it should put category employee. That would be in here as well. Let's see if it's. Yeah. Anyways, it should have put that in there. I think that's where the error came from. But just realize we do have other parameters we can utilize with the documentation commenting. Okay. Now, programming style. We got this thing called compact.java. Now let's take a look at that. And that is ugly. So if I look at that, I've got public class. I could put this entire program on one line. And when I run it, it's going to run just fine. But trying to maintain that is ugly, ugly, ugly. So I think they have us, yeah. If we go into readable, that's the same exact program. So again, that's ugly, that's readable. Okay. Now, one thing I want to point out before I get to this next, if we go to Google Classroom, I do have this cheat sheet for Windows and Macintosh. And if you click on it, it's got some different keyboard things that we can utilize. And one I want to talk about right now is this thing called format code. If I hold down the Control key and Shift key and hit F, it's going to automatically format it. With Macintosh, it's that Command key, Shift, and F. That will do it as well. And so what I want to do is, if I go in here to this one here, if I hold down my Control key and Shift key and hit F, watch what it does. It automatically formats that to in its readable format. So as you're kind of coding, if you want to make sure that it looks kind of nice, do a Control Shift F or a Command Shift F, and it will basically format your code for you automatically. Yeah, indentation, it talks about indentation, very, very important, and the Control Shift F will do that for you automatically. The next section is reading keyboard input. I want to be able to get information from my user. And to do that, I'm going to use this scanner class to do that. Okay, so let's just open up the program and then we'll talk about it. Yeah, payroll. I'll come back to these here in a second. So let's open up payroll. And so here I've got string name, int hours, double pay rate, double gross pay. Here I've got scanner, keyboard is instantiated as a new scanner, and you need to use these parameters called system.in. And system is a class, and in is some type of a static method that's in there. Okay, but notice up here I've got import java.util scanner. So scanner is not one of those classes that automatically is brought in. Before I can use it, I have to import it into this class in order to use it. So if this was commented out, watch what happens. The scanner basically gets a red squiggly line underneath it. Now here's what's really nice. I'm going to actually delete this line. If I hover over the scanner keyboard, it says, hey, do you want me to go ahead and import the scanner Java util in here automatically? Yeah, I do. I click on it and look what it did. It automatically brought in the Java util scanner. So that's nice. Java will try to help you. So now that I've got that, again, remember, the scanner keyboard on the left-hand side, that will create an empty shell of a scanner object. The right-hand side will fill it in with all of the code that it needs. So what I do is I type system.out print. Notice this is a print. What is your name space? And it's going to leave that insertion point at the end of that text. And then I say name.keyboard next line. Now what is that all about? Well, let's go back to the book, and here's what I've got. Here's the methods of the scanner class. I've got next byte, next double, next float, next int, next line. So obviously if I'm reading in a byte, I'm going to read in the next byte. If I'm using a double, I'm going to say next double, next float. And next line is for text. This is for string data. And then we've got next long, next short. Okay? So what happens is it's going to type down here in the console, what is your name? And I can type right here inside the console the name. Then it says hours.keyboard next int. I'm just going to ask, how many hours did you work this week? Then hours equals the keyboard next int. Whatever I type down here will be captured and put into hours. What is your hourly pay rate? Keyboard.next double. Whatever I type down here will be put into pay rate. Then we do our arithmetic, where I take hours times pay rate. I put that into gross pay, and then I display. Now I'm using a println this time. Hello, name. Your gross pay is $ gross pay. So let's run it. Type in my name. So I just type right here, Mark. How many hours I worked this week? I worked 38. What was my pay rate? I made 22.57. Hit the enter key. It says, hello, Mark. Your gross pay is $857.66. So this allows us to get data from our user. Now, one thing I think the book's going to cover here is reading a character. Okay? Sometimes you'll want to read a character from the keyboard. For example, your program might ask the user for a yes or no question, and you're either going to type a Y for yes or an N for no. The scanner class does not have a method for reading a single character. So what we want to do instead is this. So I've got string input, and I've got char answer. Are you having fun? Y for yes, N for no. Input equals keyboard next line. So it reads the entire whatever you type in. Then I'm going to take the answer. I'm just going to grab the very first character of the input. Remember, input is a string. I get char at 0, which grabs the very first character, and I put that into answer, which is a char. Okay. Now, mixing next line with other scanner methods. This is going to cause an issue. So let's look at input problem. So I've got string. This is identical to the last program except for this one item down here. We got string name, int age, and double income. So I've got my scanner keyboard. Now I want you to point out this keyboard, we can name this anything we want. I could call it input. I could call it stuff from the console. I could call it anything I want. This book happens to call it keyboard, and that's pretty much all they use it for. So just realize that this can be called anything that you want to call it. The book calls it keyboard, so we'll stay with keyboard. Okay, so I say, what is your age? Age equals keyboard next int. What is your annual income? Income equals keyboard next double. And then what is your name? Name equals keyboard next line. And then it's going to print, hello name, your age is age, your income is income. So let's run this, and we're going to get an error. Well, it's not really an error, but it's not going to work properly. So I type in my age, I type in my annual income, and then, what is your name? Hello, your age is 62, your income is 78. What happened here? Well, let's read on. It says, when the user types keystrokes at the keyboard, those keystrokes are stored in an area of memory that is sometimes called the keyboard buffer. Pressing the enter key causes a new line character to be stored in the keyboard buffer. So when you hit that enter key to enter that age and that annual income, that gets loaded into that keyboard buffer. So it's sitting there in the keyboard buffer. Now, since it's a new line character and not numeric, the next int doesn't see the new line character. So that's why there was no issues with the primitive values. When the user is asked to enter her name in line 28, the next line method is called. The next line method, however, is not designed to skip over initial new line characters. New line characters are textual. So when it basically executed this line of code, line 30, up here I typed an income and hit the enter key. What's sitting in the keyboard buffer right now but the new line character? So right here, name got, when it says next line, it grabbed the new line. So it looked in the keyboard buffer and it saw something there, which is new line character, and it put that into name. So then when it says hello name, So it didn't allow us to type anything in. So how do we handle that? Well, let's look at the corrected input problem. So everything's fine up to here. So I got, what is your annual income? Income equals keyboard next double. Now to clear out that buffer before we try to grab the name, we're going to clear it out. And to clear out the buffer, we just do keyboard dot next line. That just clears out that buffer. And then now when I do what is your name? Name equals keyboard next line, it should work just fine. Okay? So let's run it. What is your age? What is your annual income? What is your name? Now it says, hello, Mark, your age is 62, your income is 79,000. So now it works fine. It worked just fine, and that's basically what we want. So again, when you're doing mixed things, data types, primitive data types, and string data types, just realize if you've done any basically inserting of that and you've hit the enter key, realize that that new line character is sitting there in that buffer, and if you do a next line, it's going to try to grab that new line character. And in order to, before you utilize that, make sure you clear it out, that keyboard buffer, with just keyboard dot next line. Okay. Now let's talk about dialog boxes. So up to this point, we've been utilizing input down at the console via the scanner class in our scanner keyboard. We have access to something called the J option pane. And the J option pane will actually display a dialog box, and we can either display a message or we can display an input dialog box. We can display one or the other. Now, the J option pane doesn't automatically come with the program in that JRE system library, so we have to make sure we do an import. Okay, and so we have two. So in order to utilize that, we do have to use the import Java.ax or javax.swing.jOptionPane, and now we can utilize all of that. And so we have a couple of different methods that we can utilize. We can use what is called the show message dialog, and again we have to. It takes two parameters. We got this first parameter, we're just going to put a null in there, which is a hexadecimal 00, and then hello world. And that will display this dialog box up here, and it will say hello world in there. And then OK. And then we have an input dialog. We say jOptionPane.show input dialog, enter your name, and it's going to look just like this, and allows us to type in there and grab that. But now notice we've got name equals jOptionPane show input dialog. Now, J-option panes can only return string data. That's all it will return. So if we need numerics, we have to do a conversion. We'll cover that here in just a second. So let's take a look at names dialog. So names dialog, I got string first name, string middle name, string last name. First name is equal to, now notice I've got my import statement up here, so I can use the J-option pane. First name is equal to jOptionPane.show input dialog. What is your first name? Middle name is equal to jOptionPane.show input dialog. What is your middle name? And last name is equal to jOptionPane.show input dialog. What is your last name? Then I use the jOptionPane.show message dialog. This is not going to have any input box in there, text box. And again, we're not going to use this parameter here, so we just put a null. And it says, hello, first name, concatenate a space, concatenate middle name, concatenate a space, concatenate last name. Now, one thing I want to point out, we've got this system.exit 0. The J-option pane, even though when we hit this brace right here, which closes the program, the J-option pane can still be running in the background. We use the system.exit0 to make sure it closes anything that's running, any Jaption pane that's running, we close it before we end the program. Okay, so let's see how this works. I click on it. What is your first name? What is your middle name? What is your last name? Hello, Mark David Webb. So pretty cool. Now, converting string input to numbers. Again, we want to get data from our Jaption pane, and then we want to use it numerically. So, we have classes for each of the primitive data types. Notice the B in byte is uppercase. That is a class. We got D in double, or uppercase D double. That's a class. Float, integer, long. No, notice it's spelled all the way out. Now, each of those classes have a method that starts with parse byte. So this parse byte will convert whatever's passed to it to a byte. Parse double and parse int. So we're pretty much going to be using this double, parse double, and integer parse int. And that will basically convert it to an integer. Okay? So let's see how it looks. Let's go ahead and look at the payroll dialog. So notice I got my import statement up here. I've got public class payroll dialog. Here's my public static void main. I've got my string input string. I've got int string name, int hours, double pay rate, and double gross pay. So I've got name equals Jaption pane show input dialog. What is your name? Now I've got input string is equal. No, input string is a string. Is equal to Jaption pane show input dialog. How many hours did you work this week? Now, whatever we type in, it's going to be all numbers, but it's going to be a string data type. We need to convert it. So to convert it to integer, I use the integer class. Now, notice I didn't have to import the integer. It automatically comes with it. It's part of the JRE system library, and it basically makes it so it's automatically usable right out of the box. I do that now. If I hit the period after the integer, notice there's a whole bunch of methods that we can utilize, but what we want to utilize is the parse int. Notice I put the input string in there. This part int takes that string, converts it to an integer, and then we can then put it into hours. Then I say input string, Jaption pane show input dialog. What is your hourly pay rate? We take that input string, we send it to the double.parse double, which converts it to a double, and then we put it into pay rate. Gross pay is a double, so I say gross pay is equal to hours times pay rate. Then I use this Jaption pane show message dialog. Hello, name, your gross pay is $gross pay. So, and again, since I'm using Jaption pane, I use the system.exit0. So, hit the run. What is your name? How many hours did I work this week? How many hours did I work this week? What is my hourly pay rate? I'm going to say 27.8. And then when it runs, it says, hello, Mark. Your gross pay is $1,056.40. Click OK, and it's done. Again, the system.exit0 makes sure that any of these Jaption panes that are running are basically running are basically killed. They basically make sure they're killed. Okay, so we go back to the book. Yeah, we'll go through that program. And okay, so that's basically the end of the chapter. These common errors to avoid are a nice read. I would read those and kind of it kind of reiterates what we've covered and things you should not do. But again, if you have any questions, make sure you give me a call. We can Zoom call if you're having any issues, and we'll see you next time.